Hello everyone. The title of this video is Find the Domain and Range of a Relation. And in this video I'm going to be going over many examples in which we're given a relation. Right, and a relation can be expressed in many different ways, as a set of ordered pairs, as a mapping, as a graph. So we'll be given a relation and just simply asked to state the domain of that relation and the range of that relation, right, as their own separate sets, and I'll talk about what those are in a second. Alright, so all these exercises I'm going to do in this video are taken from a free online textbook from openstacks.org. The textbook is Intermediate Algebra 2nd edition. And the exercises I'm working on in this video are particularly from that book's section 3.5 titled Relations and Functions. And the exercises I'll be doing are numbers 283 all the way through to 294. Right, 283 to 294. That's 12 examples. Okay, and I'll be numbering them 1 through 12. Okay, so example 1 in this video will correspond to number 283, example 2 to 284, and so on. So if you'd like to see a specific problem, just count down how many exercises is that, and you can look for that example number in the description of the video. I'll have timestamps for each example in the description of the video below. Okay, so first example is this set of ordered pairs here. Okay, before I get into the example, right, let's talk a little bit about what a relation is. So a relation is just a set of ordered pairs, right, what are called ordered pairs. And every ordered pair looks like exactly like you're seeing up here, where you have a set of parentheses and some first coordinate, which is usually called the x coordinate or x value. And it's not always x, but typically it's called the x coordinate, then a comma, and then the second coordinate, most commonly referred to as the y coordinate, or y value of the ordered pair, and then close the parentheses. So that's all a relation is. It's a set of ordered pairs where each ordered pair describes a relationship. Right? Each ordered pair describes a relationship. Thus the word relation. Right? How is one value related to another? Alright, so for instance, in this set of ordered pairs here, say there are 5 ordered pairs in this set, and usually a set is surrounded by these curly braces. Right? So this is a set of 5 ordered pairs. The first ordered pair is 1, 4, so 1 and 4 are related. Then the second ordered pair is 2, 8, 2 and 8 are related. Then 3 and 12, 4 and 16, 5 and 20. Right? And all the x coordinates or first coordinates are 1, 2, 3, 4, and 5. All of the y coordinates or second coordinates 4, 8, 12, 16, and 20. All right, now a relation can be expressed in many ways. Right? One is as a set of ordered pairs, which I'm seeing here. Another is what's called a mapping. And let me show you what the mapping for this relation would look like. And you'll see mappings come up in further examples later in this video. So a mapping or an arrow diagram. Right, sometimes a mapping is referred to as an arrow diagram. So you have these two, you put up like these two boxes. Box on the left, a box on the right, and in the box on the left goes all the first coordinates, or I'll say again all the x values. In the box on the right, all the second coordinates, or all the y values. Alright, so the x values, so you got 1, 2, 3, 4, and 5, right? Those are the x coordinates, all the first coordinates of this set of ordered pairs. And then all the y values, the second coordinates. And you don't repeat them. Like if I saw the same y value twice, I wouldn't write it twice, right? This is without repeating. So I've got 4, 8, 12, 16, and 20. And then very simply, if there's an ordered pair with an x coordinate and a y coordinate, you draw an arrow from the x coordinate to the y coordinate. So there's an ordered pair, with 1, 4. So I'm going to draw an arrow from 1 in the x values to 4 in the y values. Ordered pair 2 to 8, right? So 2, they would say that 2 maps to 8, or 2 is related to 8. 3 to 12, right? 3, 12. So an arrow from 3 to 12. 4, 16. There's an arrow from 4 to 16. And 5 to 20. Right? And there you go. A very simple picture for this first example. But that is something we're going to see later called an arrow diagram or a mapping. Just another way to represent a relation, a set of ordered pairs. Another way we can represent a relation, especially when there's numbers involved, right? When the ordered pairs are of numbers, is with a graph. Right? Now, this is on the xy plane. So my horizontal axis, right, represents x coordinates, right? And this is a number line. You got 0 in the middle, positives to the right, negatives to the left. And then you have a vertical axis, which is also another number line, perpendicular to the x-axis, and this will represent the second coordinates, the y coordinates, or the y-axis. Now I'm sorry that this should be a 90-degree angle here. That's a bad hand drawing. And what you're doing to represent a relation on a graph is just finding the locations of the ordered pairs. So the first ordered pair, 1 for x, 4 for y, I go to positive 1 on the x, positive 4 on the y, and then I point out that location. Right? There's the ordered pair 1, 4, telling me that 1 and 4 are related, 1 on the x, 4 on the y. 2, 8, right? 2, 8, 5, 6, 7, 8. 2 on the x, 8 on the y, and I point out that location. And then 3, 12, 4, 16, 5, 20. All right. 3 on the x, 12 on the y. This point here, 4 on the x, 16 on the y. And then this final point up here, 5 on the x, 20 on the y-axis. Sorry that the axis doesn't go up any further. There we go. Right. But yeah, so all you're doing when if you have ordered pairs with numbers in them, you can also represent the relationships with a graph and plotting points like this. Now be careful, right? There are only 5 ordered pairs, so there should only be 5 locations pointed out in my graph. Don't draw, don't connect the dots. All right, when you connect the dots, that draws infinitely many points. We only want 5 points here. All right, you can, and we'll see graphs in later examples as well. Another way, though, I mean, you can describe in words. You can describe in words what's happening in a relation. So a mapping, a graph, you can describe it in words. Now, this isn't always easy, right? This is only if you have a pattern, right? An obvious pattern, which I'm definitely seeing here. Every single one of these x coordinates, if I multiply it by 4, gives me the y coordinate, right? 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So I could describe this in words and say the y coordinate, or the y values, are 4 times the x values. Right, there, I've described in words the relationship between the x coordinates and y coordinates in this particular set of ordered pairs, in this particular relation. Now here's the thing, if you can describe it in words, then you should also be able to write an equation for that relation. All right, so if you can see a pattern for which you can describe it in words, you should also be able to write that out as an equation. I just said the y coordinate is equal to 4 times the x coordinate. So for this particular ordered pairs, set of ordered pairs, y equals 4x. Right? The y value is equal to 4 times the x value. Now it's not for every x value on the x-axis or every y value on the y-axis, but then that's where the domain and range come in. Y equals 4x. For what values of x am I using? Right? I'm only using the values of x 1, 2, 3, 4, and 5, and the values of x, right? The first coordinates that are being used, that's the domain of the relation. Right? So now we finally get into what they want. Okay, the domain of a relation is just the set of all the first coordinates, or the x values, all right. So for instance here, and again in this first example, the domain is, it's a set, so I got the curly braces, and then I'm just listing, all the x coordinates that are used. And don't repeat anything. If there are repeats, there's no need to write them again. Right. So we got 1 in that first ordered pair, so 1 is in the domain. 2 is the x coordinate of the second ordered pair, right? So 2 is in the domain, comma, then 3, 4, and 5. And that's it. And there's the domain of this relation. And I'll put that in a box because that's part 1 of what's being asked for. And then the range, you might have guessed, is simply the set of all the second coordinates, or the y values, that are in the relation. Alright, so for this first example, right, the range, again it's a set, so I'm going to use these curly braces. And just go through the ordered pairs, and again I'm not going to repeat anything. If there are any repeats, there's no need to write them twice, you just write them once. Right? So this first ordered pair here has a y coordinate of 4, so 4 is an element of the range, comma. The next ordered pair has a second coordinate, or a y coordinate, of 8, so 8 is the next element of the range. and then 12, and then 16, and then 20. And then close the braces, and here you go. There is the range. Okay, and then you may have noticed that when I did my mapping, right, my arrow diagram, the box on the left basically just contained the domain elements. The box on the right just contains the range elements. Simple as that. Okay, so yeah, hopefully pretty easy, right? Especially if we're given a set of ordered pairs. So let's look at another, next exercise, next example. So again, we're asked to find all we're asked to do for these sets of ordered pairs now. I know for the first example, I drew a mapping and a graph, and I described it in words and wrote an equation. You don't have to do that. Right? I just did it for that first example. So these next ones should be a lot quicker. So example 2. Again, a set of 5 ordered pairs. Let me just tell you right now, not every relation has 5 ordered pairs in it, okay? You can have no 1 ordered pair, 2 ordered pairs. You can have infinitely many ordered pairs in a relation. It just, for some reason in this book that I'm going over, this intermediate algebra book here, for some reason every exercise has, 5 ordered pairs to start. Alright, so again, relation, set of ordered pairs. All we're asked to state are the domain and the range. And remember, the domain is the set of all those first coordinates of the ordered pairs, the x values, the x coordinates. So again, we have 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5, and there you go. I'm done with part 1. That's the domain of this relation, this set of ordered pairs. Alright, and the range, again, very simple. The domain was the set of all the x coordinates. The range is the set of all the y coordinates, the second coordinates. So again, it's a set, so I put the curly braces. And then for the first ordered pair, right, the y coordinate is -2, so -2 belongs to the range. Then -4, then -6, -8, -10, right, and that's it. Close the braces. There are the domain and the range of this relation, right, this set of ordered pairs. Very, very simple, I feel. And again, you could, if you wanted to, you could make a mapping with the boxes and the arrows, right, the arrow diagram. You could make a graph on the XY plane. And this one, I can see a pattern. You could describe this. Every y coordinate is just -2 times the x coordinate. So you could also write an equation for this, y equals -2x, where this is the domain and this is the range. Alright. Example 3. Another set of, again, 5 ordered pairs, right? Just be aware that not every relation has 5 ordered pairs. Alright. This time, right, in the domain, again, it's just a set with all the x coordinates, but don't repeat anything. You may notice here, 1 is an x coordinate, 5, 7, -2, and -2 again. So I'm done. Right? I already wrote -2. There's no reason to write -2 twice. Right? You're just stating what numbers appear as x coordinates when you're writing the domain. Now sometimes they'll have you write it from lowest to highest, so you would put -2 first, but this is fine for me right now. Okay, and then the range. Right, again, the set of the y coordinates, the second coordinates. So in this ordered pair, that's 7, 3, 9, -3, and 8, right? And they're all different, so I didn't have any repeats there. And like I said, very often they're going to have you put this in order from least to greatest usually, so like -3 would be first, then 3, 7, 8, and 9. These are the exact same set, right? They have the same elements in them. So again, I don't really care myself that you put it in order from least to greatest, but in some books, some homework systems, they will have you put things in order from least to greatest, or greatest to least, but in some sort of order. But that is that simple. All right. And then the last of these examples, right, then we'll get into some mappings, right? Right now all these examples have just been sets of ordered pairs. And so example 4 here is a set with, again, 5 ordered pairs. The domain is the set with the x coordinates in it, right? All the first coordinates, and just don't repeat anything though. So 11 is in the domain, -2 is in the domain, 4 is in the domain. Now I've already written 4, so I don't need to write 4 again. Okay, so 4 is just an element of the domain and no need to repeat it. And then -6. And there you go, close the braces. There's the domain of this set of ordered pairs, this relation. And you may want to put this in order from least to greatest, -6, -2, 4, and 11, whatever. I'm going to keep it this way though. Alright, then the range is the set of all the y coordinates, right? The second coordinates. So 3 is in the range, -7 is in the range, -8, 17, and 9, right? And none of those repeated, so I'm writing all of them. And there you go, that's all we are asked for. The domain of the relation and the range of the relation. Okay. Alright, so for the rest of the examples, I'm going to have the computer screen up along with my paper. As for the rest of the examples, we're going to be looking at mappings and graphs, right, instead of sets of ordered pairs. Now we're going to write sets of ordered pairs. That's the first instruction, and the rest of the examples is to list the ordered pairs of the relation, right? Write it as a set of ordered pairs as we've been seeing, and then state the domain and the range. Right? Okay, so let's take a look. Right, so hopefully you can see my paper in the lower right corner now, right? And I've got the next exercise is 287. This is going to be example 5, right? Example 5, number 287. And like I said, here we're given a mapping where we have a relationship between the name of a person and their birth date, right? And this is, like I said, a mapping or an arrow diagram. And if there's an arrow from, an element in the box on the left to an element in the box on the right, then that means there's an ordered pair there in the relation, a relationship between that name and that birthday. Maybe that person has that birthday. All right. So part 1, the set of ordered pairs, and this might take a little bit because these aren't just numbers. I got to do a little more writing. And I'll actually, do the whole thing for this first example. So I write my little set braces. And the first ordered pair I'm noticing is, Rebecca is related to January 18th. So I have the ordered pair Rebecca, comma, and January 18th. Close parentheses. There's my first ordered pair, and that represents this relationship with this arrow, Rebecca, and then the arrow to January 18. I hope that makes sense. Comma. Next ordered pair, next relationship I'm seeing, Jennifer to April 1st. All right, so I write Jennifer for the first value, the x coordinate, the first coordinate, comma, and Jennifer's birthday seems to be April 1st. So April 1st is going to be the second coordinate, right, the y value if you want, and then close parentheses, there's my second ordered pair. All right, comma. The next relationship I'm seeing is John also has a birthday of January 18th. So in parentheses, I've got John, comma, January 18. Right. Close parentheses. All right. The next relationship, next arrow I'm seeing is Hector. Hector has the June 23rd birthday. So parentheses, you got Hector, comma, June 23rd. Right. The next arrow, Luis, to February 15th. Right, so in parentheses, got Luis, comma, February 15th. Right, the next ordered pair, Ebony, has a birthday of April 7th. I'm just, again, hopefully you're looking at that arrow diagram and seeing the arrows that I'm seeing. Just working my way down. Right, so Ebony, comma, April 7th. Another comma to separate the ordered pairs. And then we have Raphael has the November 6th birthday. Raphael to November 6th. There's another ordered pair. Then we have Meredith to the August 19th birthday. So ordered pair with the first coordinate Meredith, second coordinate August 19th, comma. Next ordered pair, Karen, also has the August 19th birthday. So ordered pair Karen, comma, August 19th, parentheses, close parentheses, and another comma. And then the final ordered pair, the final arrow I'm seeing on this diagram, is Joseph has a July 30th birthday. Right, so the final ordered pair in this relation is Joseph, comma, and then the birthday that it's related to is July 30th. All right, now I'm done listing all these 10 ordered pairs here. Close the brackets, close the braces, the curly braces there. That whole set, this entire thing is the relation. Right, that was the first part. List the ordered pairs of the relation. The domain then, right, then we're asked to state the domain. Again, the domain is another set, and it's a set of all the first coordinates. So basically everybody's name, right? All the names make up the domain. So the domain has Rebecca in it. All right, and like I said at the top of this example, I'll actually show you me writing out this entire example, and then after this I'll kind of pause and skip to the end so you don't have to see me doing all this writing. So Rebecca's in the domain, Jennifer's in the domain, John, Hector, Luis, Ebony, Raphael, Meredith, Karen, and Joseph. Alright, so these 10 people, these 10 names are in the domain. And I'm closing the braces. Again, notice the domain is not here a set of ordered pairs. It's just all those first coordinates from the ordered pairs that I wrote on the previous page. Right. And then finally the range, right, equals, and again it's a set, so I put the curly braces, and it's just a set of all the birthdays, right? All the second coordinates. Now again, I don't have to repeat them, right? See, I don't have to write January 18th twice. So basically, I just write all the birthdays that are in that box, that birthday box, in the mapping diagram. So January 18th has an arrow going to it. at least one, so it's in the range. February 15th has an arrow going to it, so it's in the range. It's going to be a second coordinate in an ordered pair in this relation. April 1st, right, April 1, April 7th is in the range. June 23rd, July 30th, August 19th, and finally November 6th. Alright, so this these 8 days, right, these 8 dates are the range of this relation. Okay, so a lot of writing there, right? But it is pretty simple, I'm hoping. When you see an arrow, that arrow basically represents an ordered pair. And the values on the left, or the names, or whatever they are on the left box, make up the domain. And what they map to, where the arrows are going, those values make up the range. Right, it's as simple as that, really. Alright, so that was example 5, number 287. Let's get to example 6, and this is pretty much the same thing. So like I said, I'm not gonna write out the whole thing in front of you here. What I'm gonna do is I'm gonna start writing, and then I'll pause it on my end and come back, and what you're gonna see is just, you know, everything written up. Alright. So example 6, number 288. I'm given another, you know, arrow diagram here, names to birthdays yet again. And the first thing we're asked to do is write the relation as a list of ordered pairs. So again, the curly braces. The first ordered pair I'm seeing is Amy to February 24th. Right? So Amy, comma, February 24th. Then a comma here, and again I see a Carol to May 30th, Devin to January 5th. Alright, so what I'm going to do is I'm going to write all those out. All the arrows, all the ordered pairs represented by the arrows, and then I'll come back when it's finished. So you're going to see this just pop up here, all complete. Okay, so as I said, you just saw this all pop up on the screen now. Got, again, 10, just like in example 5, the previous exercise, 10 ordered pairs where, you know, everybody's name had an arrow going to their birthday. All right. And then after we've listed the ordered pairs of the relation like this, then we're asked to state, you know, the domain of the relation, right? The list of all the first coordinates of these ordered pairs without repeating anything. And that would just be all the names, right? So you see Amy is the first coordinate there, so Amy is in the domain. Carol, Devin, and like I did with the ordered pairs, I'm just going to pause it here and you'll see this just completed when I'm done writing all 10 names that are in the domain. Okay, so here we go. Right, Amy, Carol, Devin, Harrison, Jackson, LeBron, Mason, Natalie, Paul, and Sylvester. Right, those are all the names, all the first coordinates of the ordered pairs, and those make up the domain. Right. And the same thing goes for the range. Right, the range is just all the second coordinates, right, where all the arrows are pointing to, right, where the arrowheads are in the diagram. And so, like, you know, and these are all the birthdays, right? February 24th for Amy's birthday, and then May 30th, and again, just no need to repeat anything. Now, notice that there's, in this particular picture, there isn't any birthday with more than one arrow coming to it, so there are no repeats. Right? So you're going to have all 10 birthdays in this set. So just like before, alright, I'm going to just write them all out, and when I come back, when you see the video, you know, you'll see them all just pop up on screen here. when I'm done. Okay, and there they are, all 10 of the birthdays that showed up, listed in a set, all the second coordinates of my ordered pairs, thus the range of this relation. Alright, and this is another relation that you could describe in words, right? I mentioned at the top of the video the first example. Sometimes relations can be described in words, right? We just simply say, a person's birthday. A person is related to their birthday in this particular one. Now, obviously, because these aren't numbers exactly, wouldn't really have an equation for this. Right? And I wouldn't be able to really put this on a graph, maybe. So a set of ordered pairs and a mapping are really probably the best ways to represent something like this. Okay, so that was example 6, exercise 288 there. Exercise 289 is going to be example 7, and it's the same thing, the same instructions. Write the relation as a set of ordered pairs, then state the domain of the relation, state the range. But this time it's not names to birthdays. It's, if I read this here, it's for a woman of a height 5 feet 4 inches. The mapping below shows the corresponding body mass index, or BMI. The body mass index is a measurement of body fat based on height and weight. A BMI of 18.5 to 24.9 is considered healthy. So we're seeing a weight. This is for women that are heights, a height of 5'4". Seeing here weights 100 pounds. I don't know what the plus is for because all these are plus 100 anyway. 100 pounds to 17.2 BMI, and these are for just individual women. It looks like 7 women that are 5'4" are taken here of different weights, and they have different BMIs. And again, each arrow represents a different relationship, right, and a different ordered pair in the relation. So for example 7, in this relation, the first ordered pair here, my first coordinates are going to be the weights of these 5'4" women. Right, the first one was 100 pounds, and that woman had a BMI of 17.2. Right, so the first coordinate will be weight, the second coordinate will be their BMI, and there's an ordered pair. Comma. Next one I'm seeing is 110 pound lady, 5'4" woman, has a BMI of 18.9, right, just following the arrow. And there should be 7 of these, right? You see there are 7 weights on the left side there. And then the 120 pound woman had a BMI of 20.6. A 130 pound 5'4" woman would have a BMI of 22.3. A 140 pound 5'4" woman would have a BMI of 24.0, or just 24. A 150 pound 5'4" woman would have a BMI of 25.7. And finally, a 160 pound woman that's 5'4" would have a BMI of 27.5. Right. And then that's all 7 ordered pairs. Those are all 7 arrows I'm seeing in this diagram. So I'll close the braces, and there's the relation, represented as a set of ordered pairs. Okay. Pretty simple, just like the previous 2 examples. Then we're asked to state the domain. The domain is again just a set of all the first coordinates, all the x coordinates if you want to call them that. In this case, it's the weights, right? All the weights of these 5'4" women. So we have 100 pounds, 110 pounds, 120 pounds, 130, 140, 150, and 160 right there. There were 7 of those weights. And there you go, the domain has these 7 elements in it. And the range, right, the range is the BMIs, right, all the second coordinates in my ordered pairs, or where the arrowheads are pointing to in my diagram. So we have 17.2, 18.9, 20.6, 22.3, 24.0, 25.7, and 27.5, right? And there were no repeats, right? So there were 7 values in the domain and no repeated values in the range. So as I'm seeing 7 values in the range as well. And there we go. That is all I was asked to do for this exercise. Just like exercises, examples 5 and 6. All right, so yet again, same thing, but this time it's the BMIs for women of height 5'11". All right, so a 130-pound woman that's 5'11" would have a BMI of 18.1, and so on. All right, so I'm just gonna, kind of like I did in some previous exercises, I'll start writing it for you, and then I'm gonna pause it, and when I come back, you'll see it just kind of all written out right away. So, again, the first ordered pair here, the weight, 130-pound woman who's 5'11", comma, and then the second coordinates will be BMI again, would have a BMI of 18.1. Right. And then the next ordered pair, right, 140-pound woman, that's 5'11", would have a BMI of 19.5, right, if you follow the arrows. And I'm gonna just write out the rest, and you'll see it complete when I'm done. Okay, so here they are, right, all of these 8 ordered pairs, right, corresponding to the 8 different arrows I'm seeing in the diagram. Right, and then after the relation is written as this set of ordered pairs, we state the domain, which again is just the set of all the first coordinates, and here all the first coordinates are just the weights of these 5'11" women. So 130 pounds, that belongs to the domain, 140, 150, all the way up to 200. Right, that won't take me that long to write here. And there you go, there's the domain of this relation, right? The set of all the first coordinates, all the weights. And then the range, right, is the set of all the y coordinates, or the second coordinates, which again, it shouldn't take me that long to write these. You got 18.1, these are the BMIs. 18.1, 19.5, 20.9, 22.3, 23.7, 25.1, 26.5, and finally 27.9. There's the 8 different BMIs that show up as second coordinates, that show up in this diagram as a second coordinate. Right? And there you go. Right, just like examples 5, 6, and 7. Very, very simple. Just time consuming. Right? It just takes a bit to write this stuff out. That's all. Okay. So now in the last examples, so starting with example 9 here, this will be exercise 291. We're given the same instructions, right? We're again asked to list the ordered pairs, and then find the relation, then find the domain of the relation, and find the range of the relation. But this time, instead of a mapping, we're given a graph. Now, I hope you can see these little light green points on the graph that represent the ordered pairs. All right, I'm hoping you can see those. And they're telling us, right, horizontal axis represents x values, so first coordinates of the ordered pairs. The vertical axis is y axis, represents the y values of the second coordinates of the ordered pairs. All right, so again, I'll write a curly braces here, and then first I'm going to write this relation, right? This set of, looks like there are 6 ordered pairs here, right? There are 6 points being highlighted on the graph. I'm going to write this as a set of 6 ordered pairs with the curly braces. All right, so the first ordered pair, let me start in the upper left here. Right, this point where my cursor, hopefully you can see my cursor floating around too. This light green point is above, -3 on the x-axis. So the x-coordinate is -3. So I'll write that first, -3, comma. And that point is in line with +4 on the y-axis. So it has a y-coordinate of +4. So that first point, right, this first light green point in the upper left-hand corner of the graph here, this represents the ordered pair -3, 4. Or you could say that -3 maps to 4, or -3 is related to 4, however you want to say that. All right, then a comma, and then another ordered pair. Just going left to right here. This point, this light green point, where my cursor just moved to, it's in line with -2 on the x-axis and -1 on the y-axis. So there's the ordered pair -2, -1. All right, then moving my cursor to this point, all right, pointing at this point down here. That's in line with 0 on the x-axis and -3 on the y-axis. All right. Then this point, where my cursor just moved, it's hovering around, that's in line with 2 on the x-axis and +3 on the y-axis. So I got the ordered pair 2, 3. Then this point here, and this point where my cursor is floating around, pointing to, this point is in line with +4 on the x-axis, the horizontal axis, right? And it's in line with -1 on the vertical axis, or the y-axis. So that's the point, the ordered pair 4, -1. All right, and then finally, the last point in the lower right corner here. This is in line with +4 on the x and -3 on the y. So 4, -3. Okay, so there we go. And then I close the braces, and there's a set of 6 ordered pairs, right? This relation with 6 ordered pairs, these 6 points on this graph. So that's the first thing we were asked to do. Then state the domain. All right, the domain is again a set, so I put the curly braces. And it's the set with all the x coordinates, all the first coordinates of these points. And don't repeat anything, right? There's no need to write the same thing twice. So if you look at all these ordered pairs, all the first coordinates, right to the left of the commas, you got -3 is in the domain, -2 is in the domain, 0, 2, 4, and 4 again. But I already wrote 4. So I don't need to write it again. Okay, so there's your domain. -3, -2, 0, 2, and 4. All the x coordinates being used in these ordered pairs. And then the range, right? The range is all the y coordinates, all the second values. Again, without repeating anything. So first ordered pair, you got a y coordinate of 4. Then second ordered pair, you got a y coordinate of -1. Then -3, and +3, now -1 I've already written, so I'm not going to write it again. -3 I've already written, so I'm not going to write it again. So that's it. All right, just these 4 values. Now again, if you want to write them in order from least to greatest, be my guest, but I'm going to leave it this way. Yeah, no need to repeat anything, right? You're just listing the y coordinates that are used in the ordered pairs of this relation. And that's it. All right, that is all I'm asked to do for exercise 291 there, example 9. All right, let's keep moving. Right, example 10. Same instructions, right? I'm given another graph here. This is exercise 292. Then there are 1, 2, 3, 4, 5, 6 points on this graph again. So I'll just go left to right one more time. So again, first thing I'm doing is writing this as a set of ordered pairs. Looking at each of these points that are plotted, these light green points, or light blue or aquamarine, whatever you want to call them. All right. So this point here, where my cursor is floating around, that's in line with -3 on the x-axis, and it's in line with +4 on the y-axis. So that's the ordered pair -3, 4. All right. Comma, then there's a point directly below that that's in line with -3 on the x and -4 on the y. Right, so -3 for the x coordinate and -4 for the y coordinate. So -3, -4. There's another second ordered pair. This point here is in line with -2 on the x and 0 on the y. So -2, 0. Next ordered pair, next point, this one here is in line with -1 on the x, +3 on the y, so -1, 3. This point up here is in line with 1 on the x and 5 on the y, so 1, 5. And the final point is this one over here, which is in line with 4 on the x and -2 on the y-axis, so 4, -2. Okay, and then I close the braces. Again, we have this relation with 6 ordered pairs. And when I'm stating the domain, right, I'm listing the x coordinates that are used without repeating any of them. Right? There's no need to write these numbers twice. So -3 is in the domain. -3 again, but I've already written -3, so I don't need to write it again. Then we have -2 is in the domain, -1, +1, and +4. And close the braces. There's the domain. And the range, right? The range is again the set of the second coordinates, all the y values, without repeating anything. So +4, right? -4, 0, 3, 5, and -2, and none of those repeated. Right? So there are 6 values in the range, only 5 in the domain, but 6 in the range. Right. And great, that's it. Now again, if you want to, you can write this in order from least to greatest. You know, go -4, -2, 0, 3, 4, and 5. Doesn't matter though, it's the same set. Alright, moving right along. So exercise 293 will be example 11. Again, I have six dots, 6 points, right? 6 ordered pairs in the relation. So I'll do this a little more quickly than I did example 9 and 10. Alright, so I'm doing the set of ordered pairs, right? This first one up here that I'm pointing at with the cursor. Got -1 for x, +4 for y, right? -1, 4. But then there's one down here with -1 for x, -4 for y. Right? Then you have, 0, 3, 0, -3, right down here. This point would be 1, 4, and then this last point, 1, -4. And there you go, right? Another set of just 6 ordered pairs. Alright, the domain. Just a set of the x coordinates, right? The first coordinates. So -1 is in the domain. -1 again, right? But I've already written -1, so I don't need to write that. Then 0 is in the domain. 0 again, but I've already written it. 1 is in the domain, and 1 again, but I've already written 1. Right? So just -1, 0, and 1 are the elements of the domain. Then the range, right, is the set of the y coordinates, the second values, so 4, -4, 3 and -3, and 4 and -4 again. No need to write those. I've already written 4 and -4. So the only values in the range are 4, -4, 3, and -3. And there you go. Simple as that. Very, very simple stuff, I feel. Alright, then I just got one more of these. Alright, this graph here with yet again 6 ordered pairs. Please understand that not every relation has a graph with 6 ordered pairs. Right? It's just for these examples, they happen to have 6 ordered pairs. You can have more, you can have less, you can have infinitely many, whatever. Right? So final example here, example 12. This is exercise 294. So same deal, right? I'm going to make a curly set of braces and list the 6 ordered pairs that are represented by these 6 dots, these 6 light green points, and I'm going to go from left to right. So this point down here is -2, -6, right? -2 for x, comma, -6 for y. This point here, -1, -3. This point here is 0, 0, right? The origin of the coordinate plane. This point here, now notice how it's like between stuff. So I'm just going to say that this point is halfway between 0 and 1 on the x and halfway between 1 and 2 on the y, just to make it easy for me. So half for the x, 1/2 for the x, and then 1.5 for the y coordinate. So that's 3/2. Right? I don't like writing mixed numbers. If you want to write a mixed number, 1.5 or 1.5, if you like decimals, that's fine too. But 1/2 for the x, 3/2 or 1.5 for the y. Then this point is 1, 3. And this point here, final point, is 2, 6. So there you go. There are the 6 ordered pairs for that relation. And the domain, right? The domain is the set of all the x coordinates, right? All the first coordinates. So you got -2, -1, 0, 1/2, or 0.5, whatever you want to write. That's equivalent to 1/2, 1, and 2. Right, there's the domain. And then the range, yet again, is the set of all the y coordinates, right? All the second values in my ordered pairs. So -6, -3, 0, 3/2 or 1.5 or 1.5, whatever you want to write, that's equivalent to that. +3 and +6. And there you go. The domain and range and the relation, expressed as a set of ordered pairs instead of a graph. Wonderful. All right, so there's a lot of examples there, right? 12 examples where we're given a relation either as a set of ordered pairs or as a mapping, right? One of those arrow diagrams, or as a graph. And it has to state the domain, right? The set of all the x coordinates, the first coordinates of the ordered pairs, and state the range, the set of all the y coordinates or second coordinates. And hopefully watching me go over these several examples, these many examples, help you when you're working on similar problems. And thank you very much for watching.